class, welcome to Playing Tricks in Mathematics. Today we want to look at mixed operations. If you have a mathematical question that has more than one basic operations in it, what you have is a mixed operation. And there are rules that you need to follow in order to solve questions under mixed operations correctly. 1. Addition and subtraction only. If you have a mixed operation question that has only addition and subtraction operations only, what you do is to solve it from left to right. Let's look at an example for us to understand this better. Examples. 1. Let's say you have a question that says solve 11 minus 10 plus 3. You can see in this question we already have subtraction and addition. So what do? You first of all do 11 minus 10. That is 1 plus 3. So the answer for this one is 4. So you solve from left to right. Why do you have to do that? Is because in this question, the addition and subtraction have equal strength. Strength determines the order of operation in mathematics. Let's look at another question to understand it more. Let's say you have a question that says evaluate 16 minus 8 plus 9 minus 10 minus 3 plus 11. If you look at this question very well, it's more complex than the one we just did. And in this question, we have only addition and subtraction operation. So due to that, we solve from left to right, because in this question, addition and subtraction have equal strength. So we start 16 minus 8. 8. You have 8 plus 9 minus 10 minus 3 plus 11. 8 plus 9, you have 17 minus 10 minus 3 plus 11. 17 minus 10, you have 7 minus 3 plus 11. 7 minus 3 is 4 plus 11. The final answer is 15. Let me give you a little warning. When you are working under mixed operation, solve the question stepwisely. Don't rush yourself, because if you do, there might be error that will make your final answer to be incorrect. So solve it step by step so as to avoid the error. Let's look at another example under this. Let's say you have a question that says solve 2.5 plus 1.5 minus 0.5, right? Since you have only addition and subtraction operation, you can solve from left to right. 2.5 plus 1.5. 5 plus 5, 0. 2 plus 1, 3. Plus the one you are keeping, that is 4. So we have 4.0. So 4.0 minus 0.5. So 4.0 minus 0.5. 0 minus 5 is impossible. You borrow 1 to this is 10. 10 minus 5, 5. What you have here is 3. 3 minus 0, 3. So the answer to this is 3.5. So this is how to solve it step by step. Let's look at final question under this. Simplify 2 over 3 plus 1 over 4 minus 1 over 3. Now, if you look at the question again, it has only addition and subtraction. Therefore, we have to solve from here to here. Then, if you look at it, they are all fractions. So we can look for the LCM of the denominator. So the LCM of 3, 4, 3 is 12. So we have 12. 3 in 12. 4. 4 times 2. 8. Plus 4 in 12. 3. 3 times 1. 3. Minus 3 in 12. 4. 4 times 1. 4. As usual, you solve from here to here. 8 plus 3. 11. Minus 4 over 12. And 11 minus 4, that is 7 over 12. So that is this row. Let's look at another row. Multiplication and division only. If you have only multiplication and division in the question, you also solve from left to right. Why? It's because in that question, multiplication and division have the same strength. So the ideal thing is to solve from left to right. Let's look at some examples to understand what we are saying better. Now let's say you have a question that says solve 16 times 10 divided by 5. Now, in this question, you see that we only have multiplication and division. So the ideal thing to do is to solve from here to here. So from left to right, 16 times 10, that is 160 divided by 5. So we can write it again and say 160 over 5. 5 here 1, 5 in 16, we have the remaining the 1. So this will become 10. 5 in 10, 2. So the final answer for this is 32. Let's look at another one. Let's say you have a question that says simplify 7.5 divided by 1.5 times 0.1. Likewise, in this question, we only have division and multiplication. So it is ideal that we solve from left to right. So the next thing for us to do is to convert this one to whole number, the 7.5 to whole number, 1.5 to whole number. Change it by using equivalent operation. This moves one place. This also moves one place. Right? So that means 7.5 over 1.5. We multiply this one by 10. We multiply this one by 10. It is this one place that tells us that we should multiply it by 10 to convert it to whole number. So this will be 7.5. This 0 will carry this 5 here. So we have 75. This 0 will carry this 5 behind the decimal. We have 15 times 0.1. So 15 is 75. We have 5 times 0.1. So then, to multiply this, we can move this decimal behind the number to show that we are moving one place, right? So then we can now convert this one to whole number. So we now have 5 times 1, and 5 times 1 is 5. The decimal is there, so this decimal we have removed here, we have to return it back to its normal position. So we now have 0.5 as our final answer. So that is how to solve that. Let's look at another example under this that involves fractions. Let's look at another example that involves fraction. Let's say you have a question that says simplify 1 whole number 3 over 4 times 2 over 3 times divided by 1 over 4. Now, if you look at this question, we only have multiplication and division operations. Then you solve from here to here, that is from left to right. The first thing we do is to convert this mixed number into an improper fraction. Let's do that. So 4 times 1, 4 plus 3. We have 7 over 4 times 2 over 3 times, divided by 1 over 4. So then, since we are solving from left to right, you can multiply this and multiply this out. 7 times 2, 14. 4 times 3, 12. Divided by 1 over 4. So here we can apply the rule of division, that any number or fraction behind the division sign, we have to undergo inverse process. That is, the denominator will move to numerator and numerator will move to denominator. So let's do that. So 14 over 12 times 4 over 1. So 4 here 1, 4 here 3 to make it fast. So we have 14 times 1 over 3 times 1. So this is 14 times 1, 14 over 3. How many 3 can we see in 14? 4. What do you have left? 2. 2 over 3. So the final answer is 4 number 2 over 3. Please note this. In mathematics, off means multiplication. So anywhere you say off in mathematics, it means multiplication. So don't forget. When we started this topic, I explained that the order of operations in mathematics depends on the strength of each mathematical operation in the question. Rule of BODMAS or BIDMAS. In some places, they call it BODMAS, while in some places, they call it BIDMAS. What is the meaning of BODMAS? Let's look at the meaning of BODMAS. B means bracket. O means others. D means division. M means multiplication. A means addition. And S means subtraction. Alright. Let's look at big mass. B is also brackets, just like in the board mass. I is indices or power. D is division. M is multiplication. A is addition. And S is subtraction. So that is the meaning of board mass and big mass. So this rule is the one that is telling us the order of operations in mathematics. So it's telling us how this operation will work in a particular question. So if you move like this is the decreasing order of the strength. So you are moving from the strongest to the weakest. If you move like this is increasing order of the strength. So this is the weakest and this is the what? Strongest. The same thing in what? In big mass. And what is this thing actually telling us? It's telling us that in a question, you have to solve bracket first, followed by others, followed by division, multiplication, addition, and subtraction. The same thing here. You go with bracket first, indices or power, division next, followed by multiplication, addition, and subtraction. So it's just telling you the order of operations in mathematics, so that it's just like a guide to help us to accurate or correct answer. Now let's look at how do we apply this rule. Let's go by way of examples. Let's use examples to understand it very well. Let's say you have a question that says 1. Solve 18 minus 3 times 3 divided by 4 plus 1 times 6. If you look at this question very well, you see that this question is different from the only addition and subtraction, and as well as only multiplication and division that we did earlier. This one, you have subtraction, you have multiplication, you have division, you have addition. So you have to apply the rule of odd mass or big mass, as the case may be. So that means you have to solve the numbers inside the bracket first. So this will be 18 minus 3. You have 15 times 3 divided by 4 plus 1, 5 times 6. Now if you look at this step we are now, we have only multiplication and division. So we can apply the rule of only multiplication and division by solving from here to here. So this one will now be 15 times 3, 45 divided by 5 times 6, right? So this is 45 over 5. You know, this division sign can also be written like this, times 6 over 1. 5 here 1, 5 here 9. So what do we have? We have 9 times 6 over 1 times 1. And 9 times 6 is 54 over 1. So the final answer is 54. Like I always say, in this operation, solve it step by step. Don't rush yourself. Let's look at another example. Example 2. Let's say I have a question that says simplify 6 plus 9 minus 5 times 10 divided by 5 plus half of 25 minus 90 minus 25 plus 5. So look at the question. We have many operations in it. We have addition, subtraction, and multiplication, division, addition again of brackets. Inside bracket we have subtraction, we have addition. So following the rule of board mass, we'll have to solve the one inside the bracket first. So that is the strongest order, right? So this is 90 minus 25. That is 65 plus 5, that is 70. So we now have 6 plus 9 minus 5 times 10 divided by divided by 5 plus half. Half is now times 70, right? Following the order, the next order should be division. That is, the next operation should be division. So let's go with the division. So we now have 6 plus 9 minus 5 times 10 divided by 5, that is 2, plus half times 70. So the next operation should be multiplication. So let's do with the multiplication. So we now have 6 plus 9 minus 5 times 2, 10, plus this one is this, 2 here 1, 2 here 35. So 1 times 35, 35 divided by 1. So here we have 35 straight. So now we have only addition and subtraction. So we can solve from here to here. So this is 6 plus 9, 15, minus 10 plus 35. 15 minus 10, 5, plus 35 equals 40. So the final answer is 40. So that is how to apply Bodman's or Bigman's in mathematics. Now let's look at another concept. Mixed operations in fractions. We want to look at how Bodman's can be applied in fractions. Let's look at examples to understand the concept better. Let's say you have a question that says simplify 3 over 5 plus 4 over 5 minus 2 over 3 divided by 2 over 7. So, you see, in this question we have more than one operation, and it's not just only addition and subtraction, we also have division. So we apply the rule of Bodman's or Bigman's. Solve the one in bracket first. So we have 3 over 5 plus the SM of 5 and 3 is 15. 5 in 15, 3. 3 times 4, 12. Minus 3 in 5. 3 in 15, 5. So 5 times 2, 10. Divided by 2 over 7. Now, we now have 3 over 5 plus 2 over 15 divided by 2 over 7. In the next operation should be division. So this fraction will undergo inverse operation. So this one will go up, this one will come down. So we have 3 over 5 plus 2 over 15 times 7 over 2. 7 over 2, yes. So 2 here 1, 2 here 1. So we now have 3 over 5 plus 1 over 15 times 7 over 1. So this is now 3 over 5 plus 7 over 15. So the SM of 5 and 15 is 15. 15, 5 in 15, 3 times 3, 9. 15 in 15, 1. 1 times 7, 7. Right? We now have 9 plus 7, that is 16 over 15. So our final answer, this is an improper fraction. We change it to this number. 15 in 16, 1. 1 over 15. So far, so good. Following all these rules that we have explained, we give you enough knowledge to be able to tackle any questions under mixed operations in mathematics. Thank you for watching and listening. Please help to like this video and other videos on our channel. Make your comment and subscribe to our channel. See you next time.